Good morning. Today we are covering the second half of lesson 7.4, parallel lines and proportional parts. You guys will be able to use proportional parts within triangles and parallel lines. So we're down here at theorem 7.7, triangle midsegment theorem. A midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So you'll notice I did not erase these numbers. What the theorem is saying is if these lines are parallel and then these individual segments are congruent to each other, then we know that our outer segment is double the length of the mid segment. So we have seen a mid-segment theorem with trapezoids. It worked a little bit differently. Now we have one with triangles where the mid-segment's just half the longer. So we're going to take a look at these. It's also asking us some angle stuff, but we can figure that out too. So on this problem, it says segment DE and FE are mid-segments of triangle ABC. So we know that these two are congruent, and these two are congruent. We also know that these are congruent because we have two pairs of midsegments. FE is a midsegment, and also DE is a midsegment. So we know a lot of things in here. There are multiple midsegments in this shape. It wants us to find the length of a B, which is totally fine. So right here, we're trying to find AB. We are given this mid-segment length, which means AB is simply double the length of the mid-segment right here. And that's it. If you want a little bit of work to show, 5 times 2 is 10. FE is this other segment. It is the mid-segment, and we are given the large segment here. So it is simply half of the large segment. So we take the large segment and we divide it by 2. So FE is 9. The last one, angle AFE, that is this angle right here. We are trying to find how big it is. Now reminder, the mid-segments have to be formed by parallel lines. So I'm going to get rid of a lot of this stuff. These two lines are parallel to each other. If this is a transversal, these are congruent. So the measure of angle AFE is 87 degrees. And that, guys, is by alternate interior angles theorem. All right, pause me. Try the U-try. Okay, hopefully you paused. It's the exact same idea. We have two mid-segments in the shape. You could just have one. It's okay, though. There are two. That means we got the congruences. These are all midpoints. We also know that we have some parallels because they are mid-segments, and that the mid-segment is half the size of the outer. So if I'm trying to find BC here, I know DF is 8, so I just multiply this by 2. It's fairly easy math. Nothing crazy is going on these problems. If I switch my focus to DE, I know it is half of the longer segment. So we just divide by 2, which is 7.5. And then, very similar to the other one, we are trying to find angle AFD. That's this angle right here. I have two parallel lines. I have this transversal. these two angles are congruent by alternate interior angles theorem. All right, well, let's continue on. So we have a vocab here, a theorem, corollary, proportional parts with parallel lines. Another special case of the triangle proportionality theorem involves 3 or more parallel lines cut by 2 transversals. Notice that if transversals A and B are extended, they form triangles with the parallel lines. So that's what this is saying down here, except now there's something we can do about it. 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So if you take a look here, you can set up a proportion of AB over BC equals EF over FG. That's what this is saying here. So we can do that on these problems. So it says, use proportional segments of transversals in the figure. We have Larch, Maple, and Nuthatch streets. They are all parallel. The figure shows the distance between city blocks. Find X. So instead of doing this as a triangle, while this is a triangle, with our proportions like the small triangle versus the large triangle, that would be a little bit more work, we can actually just set up a proportion against the sides. So we can say 26 over 13 equals X over 16. Now we still have to be careful to pair things up correctly. In this case, I just put the sides that are on the same side, or the segments that are on the same side together, so 26 and 13. Since 26 and X are in the same part of the image, they both are on top. 13 and 16 are both on bottom. Reminder, there's about 3 other ways to set up this proportion correctly. So if you set it up differently, but get this same formula, once you cross multiply, that's a totally valid way to set it up. So X ends up equaling 32, I guess units, because I don't think it gave us a unit. So X is 32. All right, you guys try the U try. Very similar. Set up your proportion, cross multiply to solve. All right, hopefully you paused. In the figure, Davis, Broad, and Main streets are all parallel. The figure shows the distance in between city blocks. Find X. So this figure looks a little bit different because the triangle is made all the way out here instead of like this one. That's okay. Totally valid. You can still set up the exact same way. So I'm going to put 8 over 24 equals X over 15. I then cross multiply. I get 24x is equal to 120. So x is equal to 5. All right. We have another corollary. Congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So these segments are parallel in this example. And these segments, individual segments, are congruent. Because that happens, these individual segments are also congruent, even though they're not marked. We know that has to be the case. So we can use this idea to solve algebra, okay? Use congruent segments of transversals. This is one of the only times that we actually have congruent segments and we're not setting up a proportion here, is when they are actually marked congruent. So these two have a congruent marking. We know they are going to equal each other. We also are going to have to solve for y. These two do not have a congruence marking, but because we have parallel lines and these are marked congruent, we know these y are also congruent. So we have 9y minus 2 equals 6y plus 4. And then we just solve these. Simple algebra from here. I'm going to subtract x, add 7. We have 2x equals 12, which means that x is equal to 6. And we do not have to plug it back in because it just asks us to find x. And then on this other one, I'm going to add 2 to both sides, subtract 6y. I get 3y is equal to 6. So y is 2. All right, pause me. Try the you try. Okay, hopefully you paused. This one, I will say, is a little bit more confusing because there's some fraction stuff going on. You can still totally figure it out, though. These are congruent. They're marked congruent, so you set them equal. 4a minus 5 equals 3a plus 6. We subtract 3a on both sides. Add 5 on both sides. We get that a is 11. Easy peasy. The other one's setup is fine. These two have to be congruent to each other since the other side was, and these are parallel lines. So we have 3b equals 5 over 3b plus 2. Okay, so right away we have to deal with this fraction. I am going to subtract 5 over 3b on both sides, canceling this one out. Now, if you have some fraction sense, you know that you can write 3 as the fraction 9 over 3, because if you were to reduce this, it is 3, right? We needed a common denominator, so I just multiplied both of these by 3 to get that. So I could switch this out to 9 over 3 and just subtract. And that's probably your best option, because if you don't, you're going to end up with repeating decimals, and then you're going to end up rounding, and it's going to be off. So that's how you can switch a whole number to a fraction number with a certain denominator. This still equals 2. Now that we have a fraction on the left side, to get rid of a fraction you can't divide, you have to multiply by the flipped version. So these cancel each other out, leaving b by itself. So we now have, when we multiply, 6 over 4. And then when we reduce, 3 over 2. And if you want to write it as a decimal, it's simply 1.5. So I would take either of these two answers, unless I specifically said fraction or specifically said decimal. Okay? So that one's a little bit trickier, but we made it to the end. All right, with the rest of class time, work on finishing the 7-3, 7-4 delta. You can now do that last section since we finished 7-4. If you have finished already, flip your paper and work on the worksheet that goes with this information. Have a great day, guys.